Okay, so this will be the last problem for this section. Now, this problem is going to be a little bit different than the other problems that I've done. Mainly, in the answer to this problem, we're going to end up getting an integral as a portion of the answer, because the integral of any e to whatever x divided by x, there's no fundamental way, there's no fundamental solution for it. There are certain integrals out there, like the integral of sine of x divided by x. There's no normal method, well, I speak of this in the normal techniques of integration, of actually finding the integral of that problem. Can we find the integral of that problem? Yes, but it ends up becoming a Maclaurin series, the activity you did in calculus 2. And we had the only way to get to the integral of sine of x divided by x was to take the Maclaurin series of sine of x, divide everybody by x, and then integrate each part individually, and you get a series representation of the integral of sine of x divided by x. But there are certain integrals out there that our normal techniques of integration just aren't enough to do. Like, I would say even the integral of e to the minus x squared. You don't figure out how to integrate that until calculus 3, because the only way I'm familiar with integrating besides using the series is the transformation into polar coordinates. So, and using variables of x and y. Anyway. Okay, so let's go ahead and try to tackle this problem. So, like on all the previous problems, we are going to begin with the auxiliary equation, the homogeneous portion of the problem. So, m squared minus 4 is going to equal 0. So this is saying m minus 2, m plus 2 is going to equal 0, or that m1 equals 2, and m2 equals negative 2. I'm going to have to get a new marker. 1 week has already killed Sharpie. Okay, so what is that telling me? That's telling me that the complementary solution, y sub c, is going to be c1 e to the 2x plus c2 e to the minus 2x. So that's our c1y1 plus c2y2. So, okay, so we have our complementary solution. Let's go ahead and find w, w1, w2, so that we get u1 prime, u2 prime, then get u1 and u2, and then we slap all of that together and get our complete solution. So, let's do w first. So remember, w is y1 and y2 and y1 prime and y2 prime. So, y1 is just e to the 2x. Bigger. All right, and then if I take this guy's derivative, it would be 2 e to the 2x. Okay, this would be e to the minus 2x, and then negative 2 e to the minus 2x. Okay, so we're taking the determinant of this thing. So if I multiply this guy and this guy right here, the 2x and the negative 2x, they cancel each other out. So that guy would just become negative 2. Then remember, I'm subtracting this one right here, but e to the 2x and e to the negative 2x will cancel each other out. So I'm just subtracting 2 again, which is going to be negative 4. Okay. All right, I think I fit W1 on this page. So, W1, so this would be 0, and then put it on the right hand side, excuse me. E to the 2x divided by x. All right, we have e to the minus 2x, and negative 2 e to the minus 2x. All right, 0, and then minus, well, right, this diagonal right there is just 0. And then e to the minus 2x and e to the 2x, they cancel each other out. And so this is just 1 over x. So that's negative 1 over x. All right. Now W2 okay, so this is e to the 2x and 2, e to the 2x and 0, and this is e to the 2x divided by x. All right. So this becomes, well, e to the 4x divided by x minus 0, which equals e to the 4x divided by x. Okay, so now we're going to look for u1 prime and u2 prime. So u1 prime, which is w1 divided by w. What would that be? So that would be negative 1 over x divided by negative 4. So that would be 1 divided by 4x. Right? And then u2 prime will be e to the 4x divided by x divided by negative 4. And I'm going to write this like this for a very specific reason. The specific reason being is that I'm going to have to set this guy up as an integral because I can't integrate e to the x over x in a normal fashion. Okay? So, this means that u1, which would be the integral of 1 over 4x with respect to x, would equal the natural log of x divided by 4. Okay, now u2, this is where it gets a little bit weird, right? So, I can't integrate that thing. So, but I want to say that u2 has to be represented by an integral, okay? And so I want it in the end to be the integral to be a function of x. So if I want the integral at the end to be a function of x, I need to make a change of variables with respect to what I'm integrating. Okay? So this is going to be negative 1 divided by 4. The integral from some x naught to x of e to the 4t divided by t, and this is an integral with respect to t. And the reason that we do a change of variables is that we don't want x's inside of here and x's in the boundary, because after you integrate it, you have to have a bar on the side with x naught and x. Well, if x's are already in the equation, then it kind of becomes redundant and messy. So that's why we make a change of variables. So we have to do this on the page. Let's go ahead and piece all of this together. So remember that so y equals c1, y1 plus c2, y2, u1, y1, u2, y2. All right. So you know what, I'm going to write this on 2 lines just so I'm not jamming everything together. Okay, so this is going to be C1 e to the 2x plus C2 e to the negative 2x, okay? Now plus U1, which is the natural log of x, divided by 4 times e to the 2x, and then minus 1 over 4, the integral from x naught to x of e to the 4t divided by t with respect to t, and then multiplied by y2, which is e to the minus 2x. That's the answer to our problem.